Good morning, folks. Get this to work. My name is Bhaskar Krishnamachari, and it's my privilege to work at USC with a brilliant group of students and collaborators at the Autonomous Networks Research Group. We design algorithms and protocols for next-generation wireless networks, and our research spans the entire spectrum from theoretical analysis and design to practical systems design, implementation, and evaluation for a wide range of next-generation wireless networks. Here are some of the kinds of networks that we look at. We've done work on low-power sensor networks, where we've designed highly efficient data collection protocols and indoor localization algorithms to enable smart buildings. We work on the design of energy-efficient sensing algorithms for mobile applications, such as automated user activity monitoring. We've designed network protocols for underwater acoustic networks, which are notoriously challenging because of the long propagation delay environments. And recently, in collaboration with GM Research, we've been working on algorithms and protocols for vehicular networks, which I want to tell you a little bit about today. So consider this scenario. You have a car that's just gone over a patch of road which has a dangerously icy condition, road condition. And the driver's fine, but the sensors have detected that there's this hazardous condition in the road at that particular point, and is communicating this information to cars going in the opposite lane through the radio on board the car. And this car in the opposite lane is able to propagate this information behind the original car to other cars so that the drivers are aware of this before they hit that patch of road and can take corrective action if needed. And of course, this example generalizes to other settings such as traffic accidents, potholes, etc. Here's another scenario. You're trying to push some kind of content to a fleet of vehicles. This content could be scheduling information, traffic updates, safety information, road closures, what have you. And increasingly, as the bandwidth on the cellular infrastructure gets more and more scarce and more expensive, we're looking for alternatives to propagate this information to a larger set of nodes. Then we can use these kinds of vehicular networks where you seed the content in a subset of the cars initially, and as they encounter each other, they're able to propagate this information virally as you would do in an epidemic. One of the technological innovations in this space that we advocate is a new kind of network architecture away from the traditional internet model of what's called address-centric networking. So on the internet, your packets are generated and routed through the network and reach their final destination based on the idea of end-to-end addressing. And so it's really centered around the idea of who generated this information and who needs it. What we advocate is that for these kinds of vehicular networks, because of their rich spatiotemporal characteristics, what you would rather be better off with in terms of overall efficiency of the network protocols is an information-centric networking paradigm, where the content and the way that content is processed and distributed through the network is organized based on what, where, and when. What is this content? Where was this piece of information generated? Where is it needed? When was this piece of information generated? Until what time is it valid? We also do research on other aspects of vehicular networks. We've been designing in-network aggregation algorithms, coded storage mechanisms for P2P file sharing applications over vehicular networks, and many others. So we believe that these kinds of wireless-enabled smart systems are definitely in our future, and there's all kinds of interesting algorithmic and protocol challenges to be addressed before we make them reality. Thank you.